Today, we'll be solving LeetCode 283, Move Zeros. The problem is straightforward. We are given an integer array called nums, and our task is to move all the zeros to the end of it while maintaining the relative order of all the non-zero elements. We must do this in place, meaning we cannot make a copy of the array. We have to rearrange the elements within the original array itself. This is a great exercise in using two pointers, a fundamental technique for array manipulation. Let's think about how we can approach this. The core challenge is to rearrange the array without disturbing the order of the non-zero numbers. A brute force method might involve creating a new array and copying all the non-zero elements first, followed by the zeros. However, the problem requires an in-place solution, so we need a smarter way. The key idea is to use a two-pointer technique. We can think of one pointer, often called the slow runner, which will keep track of the position where the next non-zero element should be placed. The other pointer, the fast runner, will simply iterate through every element in the array to look for non-zero numbers. Let's call our slow pointer non-zero index. Its job is to mark the boundary between the section of the array that we have already processed and filled with non-zero elements, and the section that we haven't fully processed yet. We start by initializing this non-zero index to 0. Then, we begin iterating through every element in the array with our fast pointer, which we can just think of as our current index in a standard for loop. As we step through each element in the array, we check, is the current element not a zero? If it is a non-zero number, we have found a value that we want to keep in the front part of our array. So, we perform a swap. We swap the element at our current fast pointer position with the element at the position pointed to by our slow runner, non-zero index. After the swap, we then increment our non-zero index pointer by 1. This action does two things. First, it places the newly found non-zero element into the correct position at the front. Second, by incrementing the pointer, it prepares a new spot for the next non-zero element we find. If the current element is a 0, we simply do nothing with our slow runner pointer and just let the fast pointer move on. The zeros will get overwritten and pushed along as we find more non-zero elements to swap into the front. Now, let's talk about the code in full detail. First, we initialize our non-zero index to 0. This variable will track the next available spot for a non-zero element. Then, we start a for loop to iterate through each index in the nums array. This is our fast pointer. Inside the loop, we have an if statement that checks if the number at the current loop index is not equal to 0. If this condition is true, meaning we found a non-zero number, we need to get it to the front. We perform a swap between the element at the current index and the element at the position of non-zero index. After the swap is done, we then increase the value of non-zero index by 1. This moves the pointer forward, ready for the next non-zero element we might find. And that's the entire algorithm. It's elegant and efficient. Now, let's discuss the time and space complexity. For time complexity, we are iterating through the array exactly once with our for loop. This means the time complexity is O of n, where n is the length of the array. This is very efficient. For space complexity, we are only using a constant amount of extra space for our integer variable, non-zero index. We are not using any additional data structures that grow with the input size, so the space complexity is O of 1. The pattern used here is the two-pointer technique, specifically a slow and fast pointer. This is an incredibly powerful pattern for solving a wide variety of array and string problems where you need to rearrange elements or remove certain elements in place. It allows us to achieve an O of n time solution without extra space. And that's how you solve LeetCode 283. Thank you for watching and let's keep learning.